So hopefully you guys can see that meter there. We have here a nightmare. So we have an 820-3115 liquid damaged that does not turn on. So let's plug it in. Just stab myself with the leads. Does not turn on. We get no green light in the charger. It does nothing. Completely dead. You can see no green light. Well, probably not. No green light. Fan doesn't spin. Completely dead. So our first rail to check, of course, is PP Bus G3 hot. And I don't know if you guys can see the meter or not. We're going to check PP Bus G3 hot, and we are getting 0 volts, of course. Now let's check and see if we have any voltage on DC in. So on DC in, we get 0 volts on one side of the fuse and 0 volts on the other side of the fuse. Now why is this? Why would a board be getting 0 volts on DC in when the charger is plugged in? Well, there's probably a short, so let's check for a short. So check for a short. Wait. I'm wrong. So check for a short. We have no short, and that's not even close. So something is pulling too much current. Now what? So I don't know, you guys aren't going to be able to see this. I'm going to try my best to show you guys. I don't know if you guys can see that, but we have a big, huge crater in the board. We have wires and a MOSFET wired in dead bug style. There's a huge crater where that MOSFET exploded, and there's a ton of wires going to the other side of the board. So it's not starting off the charger. Let's see if we can force it to start by running the DC power supply on it. So let's go ahead and solder our wires to the DC power supply, and let's see what explodes. Hopefully nothing will explode, but still, something ain't right with it. Our ground, our positive, which I'm going to solder the DC in fuse, which is going to be tricky to get to. You know what? No, just solder it right over here. Wires on my power supply are too big. And we're going to get our FLIR too and check. So we have our wires soldered on the board, and let's see. Let's plug it in. Let's see what happens. Set my voltage real low. Or 5 volts. Nothing burning me. Let's see what we're actually measuring. I'm going to turn my meter and see if we have 5 volts, see if it's being pulled down, because we're at 5 volts, 0.1 amps. Oh, the CPU is getting warm. Or is it? I don't know if the CPU is getting warm, if it's just me. So, let's see. Do we really have 5 volts on this board? We have 5 volts, so it's not being pulled down. Let's turn it up a little. Let me get my FLIR. Yes, I have a FLIR. It's not a cheap one. Well, it's kind of cheap, but it's the i3. It's a little bit older. I got this in like 2013 or something. I don't remember. You guys probably aren't going to be able to see this, but I'm going to check and see if anything's getting hot. So far, nothing really. Yeah. Flip over the board real quick and have a look. Nothing getting hot. Just normal heat on the ISL. That's normal. Let's turn this up to 16 volts. Oh, and we need to raise our amperage. So our amperage, we're almost pulling an amp, and our voltage is at 4. So let's keep something smells hot. Let's see. Whoa, we have a big problem here. I see my flux bubbling. Okay, we have a problem. So my flux is bubbling and the whole board is getting hot right there. Are you kidding me? Okay. Okay. My flux is literally burning. Okay, this is gonna be fun. So what is burnt? Is it the board under there? Probably. Okay. Let's repeal and replace. There's a current sensing resistor. This whole area is just a mess, so you know, you guys, you're not going to be able to see it, but gotta figure out what is getting hot here. Just repeal and replace all of this. Well, so we don't need current sensing right now. Let's at least get the board to start on the power supply, and then we'll worry about current sensing later. But yeah, this thing got real hot real quick, so. Is it shorted right there? No, it doesn't look shorted to ground, is it? No, it's not shorted. Or is it? Okay, so let's clean our flux up. I wish you guys can see this. This is why I need a better microscope, but let's crank up our power and see. It gets hot here. 8 volts, 9 volts, that's good enough. And we're still getting warm. Let's just crank the power and see what blows up. 12.3, and we're getting hot. Okay, what is it? My MOSFET getting hot? What's getting hot right here? This whole area of the board. So this board is internally shorted. This is going to be fun. 116 volts, and we're pulling not much, but yeah, we're getting hot. It's just the whole area of the board is warm, but I can't tell if it's from my MOSFET. I don't think it's my MOSFET. I think it's the board. CPU is roasting on an open fire. No, it's not the CPU. This is the PP bus area, and the CPU is roasting, but that's an issue for another day. Let's work on getting PP bus restored. Let's see. I'm using my FLIR to kind of guide me. Whoa, I just saw a spark. Okay, maybe we should shut off power while we dig. This is screwed. Oh, why did I choose to do this tonight? Okay. So the whole board under needs to go. So I'm just going to start scraping, and who knows what's under it. Yeah. How can I get a picture so you guys can see this? I'll take a picture so you guys can see on the screen of what I see, and then I'll put it on Facebook, whatever. Okay, so I'm going to put this up on the screen in a minute. So you guys can see it, but I don't want to share something I shouldn't. Well, not anything bad, but okay, here's what our board looks like, just so you guys know. This is what we're working on. So I'll leave that up here so you guys can see that to those coming in. But yeah. So I'm just going to scrape. I want to clean the area because I got to dig now. And I want to see exactly where the alcohol boils off. So yeah, that's the fun stuff that gets sent to me, Joshua. Yeah, you don't want This MOSFET, all this needs to go. Even though I, worked on it, it has to go. Just get out of here. Get. It's not important right now. What's important is us taking. Yeah, same here, Joshua. I don't know why I did this. I gotta get rid of our short. Well, it's not necessarily. I don't know what the issue is, but that area that it's not. There's no short reading, but that whole area of the board is extremely hot. So something's wrong there. I just wanna. Let's fix our issue first. Let's still see if it gets hot now that I took off that FET. And yeah, it's still shorted in the board. So one thing I'm tempted to do is just another day, another dollar. Yeah, that's right. Battery voltage is low. Okay, shut off now. Come on, FLIR, shut off. There we go. I'm tempted to just... Hey, I see my Flux boiling. This is cool. You know what? Let me get my... You guys need to see this. Where's my digital scope? This is something too good for me not to show everyone. What'll even be amazing is if I'll even be able to fix this. This is more just entertainment. But if I can fix it, great. If not, oh well. Learn from my experiences. So, plug in this. I can't guarantee I'm going to have this up the entire time because it's a real pain, but let's get rid of this thing. Display capture, add new, video capture device. I don't want. The microscope. Okay. So, Brendan, do you still think I could fix this after you see this? Okay. Come on. Be real. And it's even better. Let's put some alcohol here. And let's crank up the power and see what burns. So I put alcohol on it. Right. Power on. And let's watch. Kind of see where our short is. We're at max current too. So let's just watch and see what happens here. Hi from the Ashes IT. We're watching a short blow up. There's probably a VIA underneath that garbage. Thing is, I didn't do that, so I'm gonna watch and see what happens. Yep, that's right. Well, I don't think this one's gonna burn that violently. Let's turn up. No, I don't want to go any higher than that. Okay, this isn't that impressive. And my CPU is getting warm too. Okay, let's measure V-core. Do I have 12 volts on V-core? If I have 12 volts on V-core, you know what? Not today. Okay, enough of this. Let's dig. So it looks like it was coming from this via. Sorry about that. Let me try and adjust this in the way that you guys can see a little bit. 12 volts. That was 16 volts, Brendan. That was 16 volts. Surprisingly, that was 16 volts. Whoa. The whole layer is coming up. Look at this. This is going to need some more conformal coat in this. Let's just, you know what? Oh, this is just... I don't have any words for what this is. This is... What would you call this? Because I don't know. Just destroyed, I guess. This is all ground plane. This is where our short is. It just needs a little TLC. I know. I don't. This needs to go in the donut pile, but okay, let's see if our short is still there. Is our short still there? Is our short gone? Whoa. Why did that just trip? One second here, my wire slipped. Seriously, it took part of the fuse with it. Why? The fuse is fine. Needs flux. And oh, that's why my iron is burning hot. That thing's way too hot. I like to solder at like 700, not 8 something. Brendan, if you could say that just needs a little TLC, I don't know. Unless razors, if that happens all the time on razors, I don't know. That sounds depressing. Okay. Let's try this again. Get our FLIR. And then we could rebuild the PP bus circuit. And hope it works. Where did I put my infrared camera? Here it is. I think I got that short. Hey, no more short. No more short. Okay. Perfect. So our short is gone. And if you guys can see, I'll focus the microscope camera on it again. We have 16 volts. We're pulling 0 amps, so the current, we're going good. It's not pulling anything. Next thing I want to try, I want to put 12.6 volts on PP bus G3 out, and I want to see if this thing turns on. But wait a second, no, it won't turn on. Look at this area. We gotta try and solve this. Yeah, that's pretty bad, I agree. If you guys see me tilting my head that way, I'm looking at the two monitors that are there. So let's... So we're good. No more short. Okay. Alright, now let's take this step by step. I have a lot of wires run. But we're gonna redo everything. Everything needs to be redone. Okay. I hate dead bugging chips, but it's gotta be done. Should I replace the ISL again? Nah, ISL is fine. I'm gonna leave these wires. Could figure these out later, but I don't. Could reroute them, I guess. No, you know what? I just need to repeal all these wires because I'll probably screw something up if I don't. So. I think I worked on this board at 5 in the morning. Yeah, I did work on this board at 5 in the morning. Okay. Now I gotta think of how I'm gonna rebuild this since this is kind of destroyed. So, debugging chips, it kind of requires brain work. It's yeah, I don't like doing that either. I won't record like that. So, oh man, this MOSFET right here. Do I have that MOSFET? 75 amp, 16 amp, 52 watt MOSFET. Yes, MOSFET. Okay. We gotta think a little bit here. Let's place the MOSFET down how it's supposed to go. So the direction, it'll make it easier on ourselves if we put it the direction that it's supposed to go when there was actually something on that area of the board. So it went this way. And we're just really going to wire it upside down. You know what? I want to clean. I got to clean up this ground plane around here. So you're just going to rest over here for a minute. You know what? I don't want it touching anywhere, so I just want to kind of... This will be a miracle if I can make this work again. You know what, I gotta send Lewis a picture of this. Because we're just having a discussion that I get the lousiest boards. Yeah, that's pretty true. Yeah, that's... I've never had a board this is actually my first time having to dig on one of these like this, but I think it'll work. I've never really had internal board shorts like this, not this bad anyway, because the MOSFET actually exploded. He would just make poor Paul. If Paul has to get this, I feel really bad for Paul. So our big pin is going to come out here. Lewis streaming still, have both open. Okay, now this big pad, this has to go on the other side of the board. This is going to PPV-BAT something or other, I don't know. It's gonna go, pin 5 is PPDC and G3 hot charger, so where is that gonna show up? Well, it's gonna show up everywhere that's just gone. These caps, we're not gonna worry about these, they probably serve no purpose. It's gonna go on these big caps right here like I had it, so let me put my FET beside, I just wanted to place it. And remember, this is a big pad. We do not want to use little tiny jump wire. We want to use big wire. So I'm going to use my larger magnet wire. If I could find where I put my larger magnet wire. Over there, or it's probably in here. There's me constantly losing stuff. Here it is, right in front of my face. Looking all over my magnet wire, it's right here. Typical me. Losing stuff that's could not be more clear in front of my face. So, let me quickly solder these wires. I don't like this wire very much because it's thick and the enamel does not burn off very easily, so it's a chore to scrape and solder, but it is capable of carrying larger amounts of power than that little, 37 gauge or whatever it is, thin hair type wire, whatever you want to call it. Come on. There we go. Yeah, I don't like this wire. That's good enough. Now I gotta route this. I'm trying my best to make it look somewhat professional, but who cares about how it looks, as long as what matters is that fan is going to spin. That's what matters. Nothing else matters other than that fan is going to spin. Care less how the board looks, care less how unprofessional I make it look. What I care that it works. That's all that matters. You don't see the board when you're using the computer. In this case, I'm going to cut this and use sandpaper. And of course, did I seriously cut that too short? No, I'll just move it. To me to cut the wire too short, because I don't want to have to, when this MOSFET's not tied down or anything, so I don't want to I'll make this work. Just gonna put it over here. Little flux. Here's our wire. I don't know if you guys can see that. That's our first wire. Okay. Good enough. So that's our first wire, and that's for pin 5. What else goes to pin 5? Don't worry about that right now. So here's the tricky part. If you're tired, what you'll probably do is put this on backwards, but we're just going to put this on opposite. So I think kind of, you know, use your brain and think of how the chip is going to be when it's put on the right side. And so in my case, pin 5 or pin 4 is going to be this end one, right? Yeah. So pin 4, the furthest chip from me, the furthest pin from me will be the end. So that would be charger U-gate. A small wire. Now we're using our 0.1 millimeter jumper wire. What time is it? 9:21. I'm getting tired. I must finish this board though. You guys probably can't even see what I'm doing. Sorry about that. There. Okay. So charger U-gate is gonna go. Oh, I think that was our via that was messed up too. So charger U-gate's gonna go to the ISL. I think that's gonna go to pin 24. I don't remember exactly, but I think pin 24. So this is U7000 pin 24. Yeah, correct. So that's just gonna go to the ISL. Route this wire around the coil with the other wire. This board will look like a spaghetti bowl when we're done, if we ever get done. BIOS chip. BIOS chip isn't that bad to dead bug, Brendan. I mean, well, I don't know, on the on MacBooks they're only like 8 pin or something. I don't know. Razer, I don't know how many pin they are. You know what? I think I will be professional and route it. No, this is fine. No, I actually do want to route it this way. You guys probably think I'm crazy. You guys probably can't even see what I'm doing. This is better this way. Good enough. Soldered. Oh wait, no, it's not soldered. Looks soldered. Yeah, that doesn't sound fun. I can't tell if my wire's shorting on something else. I'm glad I checked. Okay. So that's one wire on the MOSFET. And I think we're almost done actually, because the other 3 pins are going to be like PPV bad, or I don't know, charger phase. So the other 3 pins are going to be charger phase, and that's just going to go to Q7035, and then we're done with the MOSFET, and then we have to work on our current sense circuit. But at least I don't know, I'm tempted to put 12 volts on the power supply and see if we get a fan spin, but I better not. Cormac, hello. I wish I could wake up from this nightmare. What's underneath it here? Nothing. Okay. So charger phase. Well, this thing won't stay still. Why won't this FET stay still? What is it? Oh, I see. Okay, I better leave that alone. I'm going to try my best to solder charger phase to this. Of course, this is going to get conformal coated all over it. I'm no way going to leave that floating around like that. Don't run away. Come on. Okay. Now you're not getting away. This is a pain. These are weak solder joints, especially the one on the end. There we go. Oh, man. Yeah, I think these are gonna, yeah, it's just gonna go to Q7035, the other FET for PP bus. Kind of want to apply tension because I want to hold my FET in place. We're just going to take this and solder it down. I don't care. It's gonna look yucky, but there, that's soldered. So now we have to put our shunt resistor down. What are you guys talking about? Okay. So now we got to put our shunt resistor down, and this is going to be fun. Since the pads are where the shunt resistor is supposed to go is completely just gone, it just dissipated, we're going to solder it to Q7085, I think. Q7080 pins 1 and 2. I'm going to go to shunt resistor. So let's get our board. Come on, suitable donor. Here we go. Let's pull that resistor and let's solder it. We're going to hand solder it, not hot air. That's the only thing I'm using hot air for is to seal it off the donor. Just to touch this ground plane right here. I'm going to try and solder it so it's sticking up a little bit, because that's not good if that touches the ground plane. I'm sorry guys, I gotta move the scope. I need the broom. And I need more heat. And there's that. Oh, that's gonna stick up in the air, but I don't care. Now I'm gonna kind of look at another board to get reference, because we have to reroute a bunch of traces, and I have no idea where those traces are supposed to go. So, let's see, do I have another 3115 in here? Wait a second. 3115 right here. So, now here's the tricky part, is figuring out which lines go where. So I'm going to have a look at how the area is supposed to look. And get my meter. Just read the board a little bit so I could route where my jumpers are supposed to go. So this is 30. So CSI RP. CSI RP has to go to the ISL, but there's 2 probe points here. So CSI RP is going to get soldered to this FET. So CSI charger current sense, whatever that stands for, I have no idea. It's going to get soldered. Where's my jumper wire? There it is. Yeah, Joshua, my business, don't give up on that. I mean, it was hard for me to start too, you know? I thought I would never get better or, you know, start up, but it did. I would always think, you know, this isn't going to get any better, you know, and then I got one board in. I had no clue what I was doing. And I fixed it. And then there's more, and then more, and then more. And Joshua, here's something you'll notice is the work is going to come in waves. You're going to get a batch, and then you're going to get nothing. You're going to get a batch, then nothing, a batch, and then nothing. And it's going to keep on being like that for a while. And then it's going to get to the point when you have so much work that you don't know what to do with. All the repairs I've had have been stupid simple. Linton ports, bad charger. You're lucky then. Wait till you get sent stuff like this. So that's gonna be CSIRP. Hope this board works. This board may not even work. This whole stream may be a complete waste of time. Would not surprise me if this doesn't work, but this is gonna go to that second resistor. Thing is, if I don't stream, this would probably never get done. It's just gonna sit, so I need to stream, because if I stream I won't stop working. I don't know what it is with me. I don't even care how this wire's routed, I just want it to work. Got it in between this cap down. The wire keeps slipping. Which are my good tweezers? Here's my good tweezers. That's good enough for now. Actually, no, I'm going to touch that up a little bit. I'm just soldering wires in the current sense. That's it. Sorry, it's not in frame right now, but I don't feel like putting it in frame. I'm tired. It's good. Now the other one has got to go. The other side of that resistor. Should we turn it on and see if we at least get a green light in the charger? At least get a green light in the charger. Hey, we have a green light in the charger. We have a green light. Now let's see if we have, we're not going to get anything on PP Push G3 out obviously, but we have a green light in the charger. Or do we? Did something just blow up? Look at this. We have a green light. You guys can't see that, but this is a start. We have PP3V42 now. Come on. We have a Here. Can you guys, any of you guys even see that? 1 second. This is gonna work. I know this is gonna work. Look at this. That is a green light in the charger. Okay, back to work. We're making progress. We have a green light at least. Yeah, now let's see if we could get that fan to spin. Then I could go to sleep. Because I want to go to sleep. I'm curious, do we get any voltage on PP bus yet? If this is like 12.56 and that fan is still not spinning, I'm done. I'm going to sleep. But if it's not, if it's something like 0, there is still hope. Come on. Green light. This DCM board's all messed up. So, what's our PP bus voltage? Please be 0, because that would give me hope. If it's 12 something and still not working. 1.55, that's hope. I go to sleep around 4 AM. No, not me. The way it's going recently, I want to be in bed by like 9. I have to solder another wire. This is gonna look like a bowl of spaghetti, but hopefully it'll work. This looks like a complete mess. I mean, this looks like some monkey got a soldering iron and did it. Not even kidding. A monkey could do this better. Look at this. Okay. A monkey could do this better. This is just ridiculous. What are you guys talking about? iPads. I have one that's supposed to be coming in, iPad Pro. Well, it's from a local shop. I don't know if he's going to send it or not, but it needs a new backlight filter. I said, okay, yeah, it's just a filter. I could do it, but we'll see if it's just a filter or not. Since when is something easy? When is something easy? Never. So I'd probably need a filter. I don't even know. I never even worked on an iPad or an iPhone. I might be getting an iPhone 6 Plus in for data recovery. That'll be interesting. If this works, I don't know. Lewis proves that that a monkey could do this better. Well, no, this is bad. My wire routing is bad. I should redo it, but I'm too tired to do that. If this thing works, it's done. Oh, ultrasonic, conformal coat, FedEx box. Simple as that. But this is just hilarious. How many wires I have run here. I mean, this is just stupid. Just stupid. Oh man, I'm tired. I can't sleep till this is done though. Be here till 1 in the morning soldering. Can't see nothing. Need a better microscope. It's time. Okay, so now we have, let's read this other board. We got to run a couple more jumper wires. What is this wire? Oh. This, I'm thinking, what in the world is this other wire sticking off this resistor, but this is just my residual. Let's see, did anything change? Do we turn on after this wire? It won't turn on. We need to run 2 more wires. But this DCM board is bad. I'm going to change this. So we need 2 more wires running. So let me look at my donor board again and see where these 2 wires go. Man, I've only been streaming an hour. It feels like longer than that. It feels like 2 hours. So on side 1 near the MOSFET, it's gotta go. Side 1, MOSFET goes to this resistor. Hopefully that resistor is still there. Yep. This one will be even funner because we're going to have to work in a very limited area. Let's see. I'm tired. Time flies and you're having fun. Yeah, I'm not having fun. Okay, if somebody has fun doing doing this wire nonsense, something's wrong with that person. This is not fun. If you find running these wires on the other side of the board like this, and this mess with a crater, and if you find that fun, please seek professional help. Urgently, too. Yeah, I don't know what individual in the right mind would find this fun. I mean, this isn't fun, but when I get paid, that's fun, you know. Not fun, but it's why I'm doing it, you know. I'm not even charging that much. I'm gonna take Lewis's advice and raise my prices. I charge $170 for this repair. Okay, now we need one more wire. Does it work now? Please just, you know, it doesn't need those other capacitors. Let's see, does this work? Come on. Please work. There's your PP bus. My fan plugged in just in case. Is the ISL screwed up? What's going on here? Let's see. .8, 1.18 volts. So it's not doing anything. Let's see. Oh, I guess PPDC and charge G3 hot charger to the current sense. Okay, yeah, that's important. We need G3 hot charger to current sense. That sounds important. This will probably start off the battery, or if I put no, that wouldn't work. Okay. Time to run a little wire. Hopefully it doesn't. It looks like a mess, but hey, who cares if it looks like a mess if it works? It looks like a spider web. That's what it looks like to me, a spider web. I'm gonna scrape my wire a little bit. Whatever. Iron's hot, it's burning me. Okay, good enough. Honestly, I'm at the point I don't care about if these joints are neat or not. I just want the stupid fan to spin. That's all I want. Just want the stupid fan to spin. That's it. Okay. Moment of truth. Will this fan spin? Will I have wasted my time? Will the fan spin? DCM board's all messed up. Oh, why no more green light? Dim green light, bad DCM board. Hey, look at this. Guys, look. That's a spinning fan. Look, this mess worked. I cannot believe this mess worked. Whatever. That's hilarious. Okay, that was a mess. I don't want to deal with that nonsense anymore. So, you know what? So, let's have an overview of this garbage. I'm just excited. This is nonsense. So look at this. Okay. I can't even tell. The resistor is sideways. Okay. We have that nonsense. Okay. Go to the other side of the board where we have this nonsense. Okay. The ISL. And then we have this. Okay, let's watch this thing. The real thing is, how long will this last? That is a spinning fan. Okay, I'm done. Good night. I don't want to see another board the rest of the night. I want to go to sleep. I don't want to deal with this right now. But that is a fixed motherboard, and that is a mess. I don't want to deal with that anymore. But that's part of the job. So thank you all for watching, and I hope you learn not to solder like a monkey like I did, but hey, if it works. So good night, and thanks.